Alright, so before I actually dive into the topics of the survey of PCAM, I want to actually talk about the logical sort process. This logical sort process is actually sort of like hidden in the textbook, but it's everywhere. And if you become really good at picking up all these logical sort process in the textbook, it makes you a better reader of the textbook. So I think that is a good side of actually knowing these type of things. It's gonna be brief, so bear with me on this one. So proof is a convincing argument expressed in the language of mathematics, and basically the proof is exactly what we do as a physical chemist. We prove something. So let's just consider one statement right here. If A is true, then B is true. You might have heard this statement in biology, maybe, that the statement A is called hypothesis, and then the B is called conclusions. So if A is true, then B is true. Okay? The way that I actually talk about this same statement is that A implies B, or A implies B by using this arrows pointing direction of the B. So whenever I actually write something like A implies B, means that A pointing arrow B means that A, if A is true, then B is true. So the B follows A, or something like this, right? So the statement, for example, let's just consider the example here. The Steve has 1 million followers on the YouTube, and then statement B could be the Steve is a YouTuber. So my hypothesis here is that Steve has 1 million followers on YouTube. If that's the case, then Steve gotta be the YouTuber, right? So for this particular combination of the statement and the statement B, A implies B is a true statement. So there are several sentences that's in the textbook that we don't have to prove when it's really obvious. Sometimes that it's obviously false, like A equal 1 is equal to 0. That's obviously false, right? And the sum of the statement, like 3x equal 5 and the y equal 1, all of these things could be true or false, depends on the value of x and y. So I don't have to do anything about these guys. But if I see the statement that says like there is an angle t such that cosine t is equal to t, in this particular case, this is not so obvious, but it's a true statement. So for this particular case, I have to show you, like I have to convince you, right, that this is a true statement. So in the textbook, these type of things are written in a way that have more explanations to it. But some of these guys just state it. And then maybe that some of the textbook says like it's straightforward, it's obvious, or something like this. But if you see something like this in a textbook, then textbook usually have why that's a true statement. That's how the textbook is actually organized. So let's just consider the example statement. If it rains, Mary bring her umbrella. So statement A is it rains, or it does not rain, right? And then statement B is Mary bring her umbrella, or Mary doesn't bring her umbrella. So to determine that statement A implies statement B is false, then you have to ask yourself that all the combination, in this particular case there is 4 combinations, A is true, B is true or false, or A is false and then B is true or false, right? There's only 4 combinations. You have to ask yourself in which of the following ongoing cases you would be calling your friends a liar. So let's just think about that one. So A is if it rains, right? So if it rains, then that's gotta be true, right? And then if it's not raining, then that's false, right? And then B right here is that Mary bring her umbrella, and then if it's false, then Mary doesn't bring her umbrella. So there is 4 combinations, right? A is true, B is true or false, A is false, B is true or false. There is only 4 combinations. So let's just think about A implies B. If A is true, B has to be true. So A is true, B has to be true. In that case, this particular case, true and true combinations, A is true, B is true, A implies B is actually a true statement. Let's move on to the next one. A is true, B is false. If A is true, B has to be true, but B is false. Then in this case, A implies B is a false statement. What about the third case right here? If A is false, that could have the consequence of the Mary bring her umbrella, or Mary doesn't bring her umbrella, the both true and false for the B, right? In this particular case, if A is false, you don't have to prove anything. It's automatically true. Let's just go back to the previous case, right? So when it doesn't rain, Mary does bring her umbrella. You would be uncomfortable calling your friends a liar on this case, right? Because if it's not raining, then you can't do anything about this statement, right? So both cases like this, it's gonna be a true statement. So A implies B always have true true become true, true false become false, and then false true, false false become true and true. So that's how the truth table actually works. So let's just think about the converse statement. I'll just try to copy this, and then okay, good. Then the converse statement. Let's think about the converse statement. For this particular case, the B implies A. So if B is true, then A has to be true, right? So for this particular case, B is true, A has to be true. So that's a true statement, right? If B is true, A has to be true, but it's false. So this one right here is a false statement. False statement. And then there is nothing to prove for this one right here. And then the next one right here, it's gonna be true too, right? Because there's nothing to prove here. Notice that the true, false, true, 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 false, true, they're not identical, right? So A implies B is not necessarily the same as B implies A. So, but in the following ongoing example here, if I change this statement to, let me just copy this, and for this particular case, if Mary brings her umbrella, then it must be raining. That's the B implies A. And that statement right here is not equivalent to A implies B. I hope you got that one. Alright, so let's move on to the next case right here. So A implies B means B implies A. As I said in the previous case, that it wasn't the same thing, right? So let's just test it out with a different case here. A implies B, right? So Steve has 1 million followers on the YouTube. That means it's absolutely the case that Steve must be the YouTuber, right? So A implies B right here is a true statement here. But let's just consider the B implies A. If the Steve is a YouTuber, does that imply that he has 1 million followers on the YouTube? I don't think so. Sometimes maybe, but not all the time, right? So A implies B doesn't mean that B implies A. They are totally different statement, mathematical statement. Now, let's move on to the and or. For the statement A and B is true, that means that both A and B must be true. If for the statement A or B is true, then at least one of them must be true. So if I have a statement that says cabbage is vegetable and grape is vegetable, because of this and situations right here, this is a false statement because grape is not a vegetable, right? But cabbage is a vegetable, that's a statement A, and then the grape is a vegetable, that's a statement B, but this is a true statement because it's or. The condition, you have to satisfy that only one, at least one of them must be true. So for this particular case, cabbage is a vegetable is a true statement. So for or case, it's a true statement. And there is another statement called if and only if, which means that A implies B and also B implies A. If, for example, like in the regular mathematical statement that you may actually see, like the 3 times 2 is equal to 6, right? This means that let me just put this 3 times 2 is a statement A, and then the 6 is B, then A implies B, and then B implies A. So it's the equal sign literally means if and only if. So let's just construct the truth table here. So both of them has to be true, right? So can I actually do this? Yeah, let me just try to. Okay, so I'm gonna have to copy these things again, and then I'm gonna paste it somewhere on here. So for this particular case, if and only if, it's the double-sided arrows, right? Then both of them has to be true. So for the first case right here, both of them is true, right? It's an and statement. If I go like this, then what is this things? Yeah, it's an and statement, right? So A implies B and B implies A. Both has to be true at the same time. So this is true, the first statement is true, and the second, first statement is true, so this has to be a true statement right here. The next one is false and true, so it's not satisfying this and statement, so this is going to be the false statement. And the third one, true and false, meaning that it's going to be a false statement right here. And then the last one, true and true, so this has to be true. So A implies B, A implies B and B implies A, so A if and only if B. In this particular case, if A is true, B is true, or if A is false, B is false. In these two cases as a true statement. Okay. So what about not A implies not B? This is sometimes called the inverse statement. So one of the examples is that the number is not even implies that that number is not divisible by 6. So can we construct a truth table out of this one? Yeah, I think you can. So let's do that. Can we do this? Yep. So, oh, that's not here. So not A implies not B, right? So if A is false, then B has to be false. So this particular case, this one is true, right? And then if A is false, B has to be false, but it's showing that B is true. So this, for this particular case, it's false. And then if A is false, then there is nothing to prove. So these become true. So true, true, false, true. Okay. So if I go back to true, true, false, true, I just need to remember this one. Do I see true, true, false, false, true? True, true, false, true. So for this particular case, it's same as this one. So B implies A is actually equal to the statement of not A implies not B. What about this one? Not B implies not A. So not B, not B implies, oops, not B implies not A. Not A. So not B implies not A. So this one is true. And then not B implies not A, but it's true, so this one is false. And then there's nothing to prove here, right? So for this particular case, it's a true, false, true, true, right? True, false, true, true. So where is the equivalent statement? True, false, true, true. It's same as this one. So A implies B literally means it's the same thing as not B implies not A. Alright, so that's good enough. Now, what I want you to do is that I want you to actually solve this problem. You don't have to actually know any of the biochemistry up to this to actually solve this problem. All you gotta do is to apply the logic. If you have any questions, ask me during the lecture time. Thanks.